Key features of graphs. So when we're talking about any type of function, whether it be linear or exponential, we always talk about if it's increasing or decreasing. So an increasing function just means as the x increases, the y increases. So one that you know for sure that increases looks like this. So that is the parent function y equals x cubed. So if you look, as your x increases, so as you move, as you move along the x-axis getting larger, the y is also increasing. So it's going up. So as the x goes up, the y values are going up. Okay. Then we talk about decreasing. Well, of course, decreasing is just the opposite of that. Decreasing function. As x increases, the y decreases. So as x is going up, the y is going down. So it would be the opposite of that graph that I just showed you. So it would start here and then go down. So as x is increasing, the y values are going down. So that is a decreasing function. Okay. You can also have a function that has both in it. So like if we talk about a parabola. So if we talk about a parabola, this one is decreasing and yes, you can hear the band this morning. So this one is decreasing. This part right here is decreasing. And then this part, this part right here, oops, that color isn't showing up, is increasing. So you can have two. You can have part of it being decreasing, part of it being increasing. And then we talk about it as an interval. So we would say this function is decreasing from negative infinity to 0, because from negative infinity way over here to 0 is decreasing. And then we say it's increasing from 0 to positive infinity. So you write it as that interval. Okay, so that's decreasing and increasing. Another thing we're going to talk about is concavity. So concavity and concavity is the description of the bending behavior. So when we talk about concavity, that's talking about when something is concave up or down. So if we say concave up, this is what up looks like. So it's concave up. I always think like a smile faces up. Concave down, concave down like a frown. Um, so concave up is just when it's facing up like this. Concave down is whenever it's down like that. Okay, so I'm going to draw an example of okay, now this one actually has both. That's why I picked this one. So if you look, this part right here is concave up. This up here is concave up. And then this down here is concave down. So this is down, and this one is up. Now, the black is the actual function. So a part of the function is concave down, and a part of the function is concave up. That point at which it switches, so it switches right there from being concave down to being concave up, that is called an inflection point. Inflection point. And that's when the graph switched from being concave up to down or vice versa. Sorry, I have to sound that out. Vice versa. Okay, so it's just when it switches. So the inflection point here is that point right there, and that's at the point 0, 0. Okay, so an inflection point is just when it switches from being concave up to being concave down. Now the last definition that we have to write down is even or odd functions. So an even function is when it is a reflection over the y-axis. So if you look, and I should have made it a better one, I'm sorry. So it should be this point and this point. I'm going to just draw that, sorry. So that would actually be it. That way you can see that it's actually a reflection over. Your notes, it doesn't really matter. Mine, it does because I need to show that it's actually a reflection. So if you look, this is a reflection of each other over the y-axis. This is also the parent function y equals x squared. So it's even because of that exponent right there. Okay, an odd function, let me write, sorry, an even function is a reflection over the y-axis. And then an odd function is a rotation of 180 degrees about the origin. So if I rotated this, I'm going to go ahead and rotate my book. Notice it looks exactly the same whenever I rotate it. So that's what it means by an odd function. This is also y equals x cubed. So it's odd because of that exponent right there. If I were to graph y equals x to the fourth, if I graph it, notice the reflection. It just has that wider base. Let's do x to the fifth. Notice that's also an odd function. To the sixth, that's an even function. So the exponent, if it's a parent, the parent function is always going to be even or odd. The only difference is if this was shifted up, it would still be an even, but if it was shifted left or right, it would no longer be an even function just because it no longer reflects over the x-axis, or y-axis, I'm sorry.